In this lesson, we are going to be talking about how to find the range of a linear function using algebraic method. In our previous lessons, we have covered how to find the range of a function of several types of function using their graph. So look out for those videos. If we are given f of x equal minus x plus 6, where x is between 0 and 4, meaning x is not greater than 4, so we are going to have 0 less than x, less than or equal x, less than or equal 4. Find the range. Solution. First, let's try to find the values of x and the corresponding y, where x is between 0 and 4. So if x is 0, y will be 6. How? Because in the function we have minus x plus 6. So if we replace 0 with x, we are going to have minus 0 plus 6, which will give us 6. Where x is 2, y will give us 4. Alright, because minus 2 plus 6 will give us plus 4. Where x is 4, y will give us 2, because minus 4 plus 6 will give us positive 2. So we can see from this that this graph will give us a line segment. But let's solve that. Let's plot the graph. If we have our axis, our y-axis, and our x-axis, and we have the points on x, we have 2, 4. I think that's all we need. And here we have 2, 4, and 6. So when x is 0, which is at the origin, y is 6. When x is 2, which is 2, y is 4. If we trace this to the point where y is 4 on the y-axis, we are going to have the point of intersection to be here. Then when x is 4, all right, this is 4, y is 2, this is 2. If we trace this, we are going to have the point of intersection to be all of this. If we join this point, we are going to have something of this nature. So how do we write the range of this function? We can say, because this is bounded, it doesn't extend to infinity. The graph is just a line segment, not an infinite line. We are going to have the range. Let's start with a set notation. So, y, right? The range, which are the y values, meaning y is a set of all real numbers, all right? But y is between 2 and 6, isn't it? Between 2 and 6. So we are going to have that 2 is less than equal y, less than or equal 6. And that will give you in a set notation. You may want to write it in interval notation because 2 is included and 6 as well is included as the maximum number there. So we are going to use a square bracket, so it's between 2 and 6, and this is the range of this function. Let's take another example. So in this example, we have that our f of s is given to be equal 2x minus 3. Now, this is a linear function, and we know a linear function is of the form y equal mx plus c, where m is the slope, and in this example, the slope is 2. All right, and what this actually means is that for every unit increase or decrease in x, there will be a 2-unit increase or decrease in y. That is what it means. That's what the slope is here. And we'll see that our c is the y-intercept. Now, how do we solve this? First method, we can uh, solve this function, equate this function in terms of x. All right, we can solve for y in terms of x, so we can say that our y is equal to x minus 3. All right, so we know that 2x minus 3 will be greater than or equal 0 for all real numbers. All right, if that is the case, it implies that our y will be greater than or equal 0 for all real numbers. But we can as well solve it another way by plotting the values of x and y. Then we can now write the range. From here we can say that the range is that y is a set of all real numbers. So here we can say that y is a set of all real numbers, and that will give us y, or we can write it in interval notation, meaning that y is a set of all real numbers. Real numbers are from negative infinity to positive infinity. Alternatively, let's write out the values of x and the corresponding y. If x is 1, when x is 1, so for every unit of 1 unit increase of x, there will be 2 units increase of y. So if x is 1, y will be 2, x is 2, y will be 4, x is 3, y will be 6. If x is 4, y will be 8. Let's go ahead and sketch the graph. We are going to have, all right, this is our y and this is our x. All right, 1, 2, 3, 4, and this will be 2, 4, 6, and 8. So when x is 1, y will be 2. All right, we are going to have the point of intersection somewhere here. When x is 2, we are going to have the point of intersection somewhere here. Y is 4. When x is 3, the point of intersection will be somewhere here. Y will be 6. And when x is 4, we are going to have the point of intersection somewhere here. If we join the line, the points together, we are going to have something of this nature. Let's go ahead and write the range that will give us, because this is continuous to infinity, it is not bounded. We are going to have that the range is which is y is a set of all real numbers. Or we can go ahead and write it in interval notation, which is from negative infinity to infinity.